Man.
All right. Hello and welcome to the Hackaday podcast. I'm Elliot Williams, Managing Editor of Hackaday.
And I'm Dan Maloney. I'm a staff writer and community engineer.
This is episode 123. We're talking radioactive rhinos, Wile-E-Coyote jetpacks, radio hacks 3 ways, and battery welders on the spot. So Mike's on vacation this week. I've got Dan Maloney filling in for him, and we are in our transcontinental Hackaday studio. I'm going to cut that out. That's dorky. So what's going on in the news this week, Dan?
I did mention it a couple times in links when the news hit that Betelgeuse was going to go supernova and we were going to get to see it, and I was so excited. And watching a star blow up in the daytime sky would have been really cool, but alas, it did not happen. But the mystery of what was causing the dimming that they thought sort of foreshadowed the impending doom of Betelgeuse has finally been solved. It basically boils down to the star burped.
What?
Well, I mean, they say it's a sneeze, but it's more. I think burp is a more apt description, and it satisfies the 12-year-old boy in me.
Right.
Basically, what happened was it emitted a big cloud of dust. Well, a big cloud of gas that then condensed and became dust. That was sort of between us and it darkened. Whatever,
got in the way
and made the star look dim for a while. And I mean, seriously dim. I thought I saw something like 30%. That's a huge amount.
By 35%, which is a huge amount.
So I mean, it was really dim. But the thing that made me interested in this story was it reminded me of all those years ago with Carl Sagan and Cosmos, where he goes through this whole soliloquy about how we are star stuff and all that stuff. And it really got me going at the time, whatever I was. It was probably in high school at the time, but it really got me going on, wow, everything that's not really simple like helium or hydrogen is pretty much cooked up in these big furnaces that in the center of solar systems. And when they go boom, they spread all that stuff all over the place for us to mine gold and be carbon and all that stuff. So it just kind of got me that we actually saw that process happen in quote unquote real time, with the light delay, but still it was kind of cool that we actually got to see that.
So it's literally stardust. It's
stardust.
Like it's kicking out stuff that it's not combusting. How rad is that?
It is. It's really cool.
This is a journey into sound.
What's that sound?
What's that sound?
Which brings us to this week's What's That Sound challenge. Last time around, it was sounds from the video game StarCraft. This time, it's going to be something entirely different. Something, Dan, which I think you stand probably a decent chance of getting.
Okay.
I don't know if that's too much of a hint.
All right. I'm psyched. Oh, I know what those are.
What? Really? Okay, what?
Oh, yeah. That's the...
That's awesome. I thought you'd have a chance, at least, of getting it right. That's super duper. Well, let's hope our listeners can get it right. If you want to submit your guess for what this is, go over to the links page for this podcast, listed at Hackaday/podcast. Give us your email and a name you would like to be referred to on the air, plus your best guess at what that sound was. And next week, we will raffle off a Hackaday t-shirt to the people with right answers. Good luck. On to the hacks. What have you got coming up this week, Dan?
Well, the first one I picked up was water slide decals for wingding keycaps by Christina Panos. The first thing that got me about this was decals. I built model fill in the blank, model planes, model cars, model whatever, all through my childhood. And the decals were always the coolest part. You pull out that sheet of decals and the level of detail on those things was amazing, especially for the space-based ones like the NASA decals and the in the logos and all that stuff, and like the crispness and detail on those things I always thought was just astonishing. And it was kind of magic to just be able to take this piece of paper with this printing on it, put it in a bit of water and slide these things off onto the model and get it just so. I loved it. It was a magical process. Johann, Yohon, I guess that would be
exclamation point.
With an exclamation point, which is probably silent. This keyboard maker, which I have to admit that this is a species of human I don't quite understand. The custom, and it's not that I don't appreciate them. It's just that sometimes the things they come up with don't look like keyboards, and they're really amazing, but I just don't get it. And I do appreciate the effort, and especially in this one, it really was kind of cool. All these wingdings, like custom pictographs, icons, I don't know what you would call them really, that he's got standing in for the character. So instead of Q, there's a crown that could go on a queen, and then W is like water waves. I ball for E, which I should be I maybe, but well, whatever. I just thought it was really a clever way to build a keyboard, first of all, and also it introduced me to the possibility, or to the fact that you can buy water slide paper for inkjet printers and print your own decals, and the wheels started turning in my head right there. That's like, wow, what can I do with that? That's a nice little piece of information.
How durable are they? Did he have any idea of like?
I think there's
you have to look at the keyboard. They're actually on the sides of the keys, right? So they're not on the part that you type, so they're not going to get finger abrasion. But I guess I was just wondering, like, how, say you were wanting to do this on a model or whatever, how likely is it to get rubbed off?
He had some sort of spray fixative or covering that with the video on there showed the process of using this. So I think that's probably sufficient, plus where they're located would make it a little bit more durable.
So what, you just buy these things, you put them in your printer, and boom.
Yeah. It's the scene in
it's almost too easy.
Yeah, the scene in Catch Me If You Can, and he's the con man. He decides he's 16 years old. He's going to be a pilot for Pan Am, so he goes and gets a Pan Am model. Right. And he gets the decals out and puts it on a check.
Yeah, exactly.
I'm not saying I'm doing that, but I'm not saying I'm not doing that either.
Exactly. Cool. My first hack this week is roller skating Wile-E-Coyote style. This is a video by Ian Charnas. He's done some really cool videos in the past. I really like his sense of humor. This one ups the YouTube factor dramatically. He has bought himself a jet engine and put up a poll asking for what he should do with it, including one of the options, strap it on your back and go around like Wile-E-Coyote on some roller skates. And of course, that's what he does. It's really awesome. This is one of those things that should be tremendously dangerous, but actually through kind of good engineering and forethought and testing and stuff, somehow totally isn't dangerous at all. The first thing he does for the jet engine is builds a test stand so that he can test fire it and get used to working with jet engines and like measure the thrust and make sure, he doesn't burn himself. Figure out what size earplugs he needs, because those things are damn loud. And then there's him trying to figure out the backpack part of it, which ends up being made out of beautiful water jet cut metal. And it's got a heat shield and it's got kind of roll bars and stuff. He's, thinking this through in the careful way you would if you were going to be the person who straps this stupid suit on. It's funny, the speed that the jet is running at is simply controlled by PWM. So he's got this little microcontroller in there just spitting out a PWM signal to fire the jet up. Who knew? Other things I learned is how difficult it is to buy jet fuel if you don't have an airplane. So you could, you can just go up to an airport and say, I'd like to buy some jet fuel. And then they say, yeah, cool, just drive your plane up around to the tank. And he's like, I got this gas tank. Or So that was pretty awesome. But he eventually found a self-service dispenser and managed to buy 2 gallons of jet fuel and take it back home for his trial, which is really cool. I don't know. It makes it look like a jet engine is something half reasonable, but I'm certain it's not.
I was a little underwhelmed by the performance at the end.
Yeah, right?
I mean, it's only, 55 pounds of thrust.
Right?
Which immediately begs the question, well, why aren't you putting 2 or 3 engines on the thing? I can see why he started with 1. But I thought the most masterful piece of trolling in the whole thing was that bit where the self-service pump wanted you to input the tail number of an aircraft.
Right.
And he says, Siri, what's Bill Gates' private jet's tail number?
And he puts it in.
And he punches that in.
Yeah.
I thought that was beautiful.
Oh, that's brutal.
And it was actually a lot of fun watching that. I tell you though, whatever shop or hackerspace or whatever he was working in, I got to get me some of that. That was beautiful.
That was exactly what I was thinking.
So much stuff.
Where does he just like walk in, put sheet metal down on a water jet cutter and cut out like, must have been 1/4-inch steel probably. Like where?
Plus a complete Lincoln welding shop.
Yeah, right.
With all the bells and whistles. I mean, wow.
The good stuff. Yeah, totally. I like this because it's an awesome demo of crazy things you can do if you just kind of put your mind to it and go through step by step. But also, Ian's done a lot of great fabrication. You should definitely check out his YouTube channel for some other builds too. Can't wait to see what he does next with it.
The next one up is an article by Jenny List about Jenny List. She did a review on battery spot welders and why you should buy a proper spot welder. I think what caught my eye about this is I'm in the market for a battery spot welder at this point. I've got a box of 100 modem batteries sitting behind me. They're all ready to be gutted for their 18650s, and I'm going to do something with them. But whatever that something is, I'm going to need a spot welder. The one that Jenny chose was of questionable quality right from the start. Cheap. Yeah, let's just put it that way. Cheap from the usual sources. And, we've all been surprised both ways, I think, by the things that have shown up on the Packet Express. I think she said this thing was only about 15 pounds, so $20 or so. Yeah. Why not give it a shot? Well, I mean, like I said, we've all had pluses and minuses in that, and I think this was kind of a pretty good minus from the look of the attempts. The attempts to weld. I guess we could say an attempt was made. It barely penetrated the nickel electrodes she was trying to spot weld. So when you can just kind of peel them off like that, you're not talking about a successful spot weld.
Yeah, you need to be able to rip the top off the battery with it.
Right. The metal's got to stay behind.
One of the two things has to give.
Yeah, so we've seen a ton of spot welder builds on Hackaday before. A lot of them with microwave oven transformers, a lot of them with supercapacitors, a lot of commercial ones too. And this one probably doesn't, it disappoints more than it satisfies, I think.
Yeah, there are a couple people in the comments who I think misinterpreted Jenny's conclusion here. She ended up saying that a battery-powered spot welder would be an awesome thing if it worked. This one doesn't. And then a bunch of people chimed in and said, oh, but there are battery-powered spot welders that work. And ironically, in that very sentence, when she's talking about it, she links to one that was on Hackaday from 2017. Where are the Watts spot welder? And this is an open design. His video of it seems extremely well thought through, and his video shows it making beautiful welds. So, there's no doubt in my mind you can make a workable battery-powered spot welder. A lot of the demand is on the battery side because these batteries have to deliver, how many hundreds/thousands of instantaneous amps, right? Like, so you need a battery that's not going to vaporize itself when you just dump like that, even though it's for a very short time. It has to have a low enough internal resistance that it can put out that much current.
Yeah, and speaking of spot welders, there's I remember there's one that I covered a long time ago. A fellow named Mark Pressling did it, Aussie guy, and it was not a battery spot welder. This is the kind of spot welder you'd see like, pulled up to the hood of a car, and popping together the panels of a car or something like that. He made this thing quite stout and very professional looking. And that was when I started following his channel, because of his attention to detail and the things that he did to make, a usable tool. He wasn't wasting his time by doing this.
Right.
By doing this build, he wanted to build a tool that would work for him and save him time, and that was always really impressive to me. So I'll throw a link to that in the show notes, because I thought that build was really amazing, and you could probably leverage some of that, some of his strategy into a battery spot welder rather than a car panel spot welder.
Who are we kidding here? You're going to be doing your battery tab welding at home anyway. You might as well just plug it in the wall.
Yeah, that's true. That's true.
And if you're like me, you've got a basement full of microwave oven transformers. And if you're unlike me, you have the nerve to build spot welders out of them.
And if you're like the rest of us, there are plenty of microwave ovens on street corners on bulk waste day, so they're easy to find.
Next up from me, Jam Hamster with Fit Your LCDs with Lenses for that vintage CRT look. He's making a little RetroPie video game console out of an LCD screen. And the problem with LCD screens is they're just so flat and perfect. And he wants this thing to look retro. And, frankly, the case on this is beautiful. And that kind of retro, bubbly, not quite in focus, curvy thing is exactly what it needed. Kudos to him for taking the effort to make this work. And the effort it is. This ends up being a 4-part post on how to make curvy, slightly distorting lenses out of acrylic and then adhere them to LCD screens. Again, he's not going for a perfect lens here. He's just going for something that's basically flat in the middle and kind of rounded at the edges. So there's a lot of creative freedom here. The coolest parts for me were like physically machining the thing to make it really round and nice and uniform without burning holes in acrylic. Because if you've ever worked acrylic, it gets hot and it melts really easily. And so part of the trick with working it is whatever you're doing, whether it's drilling or sanding in his case, is to make sure you're not trying to take too much of it out at the same time, but then also not too little. Because if you like spin the drill bit into it or your sander on the same spot, it ends up heating up and melting. So he's got this great technique where he puts the slab of acrylic on a spinning wheel, like you can think of a potter's disc, and then runs a belt sander over the side of that super gently. So you're always sanding a different part of the acrylic soon-to-be lens surface. I like that a lot. And then after that, and some painting and masking and cutting, it's time to adhere the lens to the LCD screen. And that is the subject of 2 of the 4 posts, because he put it up against the screen and noticed that there's an air gap between them, which means that there's all sorts of funny light reflections in between the acrylic and the front surface of the LCD that really just ruin the illusion of it being an old TV screen. That's where I would have been like, good enough. But not Jam Hamster, ladies and gentlemen. Jam Hamster goes and buys some of that glue that they use to glue the digitizers onto LCDs with phones. Liquid optically clear adhesive, which has the particular property that it's really runny at first, and then you UV cure it so you can get all the bubbles out and then stick it on down, and it's perfectly clear. Turns out, of course, that using it properly requires a lot of practice because it's so gloopy and because you don't want to get any hairs trapped in it and because. So read the 2 blog posts on this one if you're interested in doing something like this. Thanks, Jam Hamster, for showing us all along the way, all the little pitfalls to watch out for. This is one of those hacks that Mike would pick. Like, the end result is so good looking.
It is. And I mean, I really love the look at the end because it does remind me of sitting in front of the old, Radiation King CRT, and you get that glare. You could kind of like this, what do you call it, convex mirror, like
Yeah.
a security mirror, and you could see when your parents were coming around the corner. But if you just happen to get a dark spot on the screen, you see someone looming over your shoulder, like, "What are you watching, young man?" Like, nothing, Dad.
Exactly.
So it was kind of a nice trip back. And I thought the way that he used the bottom of the belt sander where there's no plating, so he gets this
Right.
kind of conforming grinding surface. I thought that was particularly clever in shaping the acrylic. I really like that. I did get a note from Jam Hamster that I did make a mistake on that. It was I said that the cracks appeared while grinding, but it's actually when they're exposed to solvents. So I fixed it. Mea culpa on that.
I guess it was isopropanol or some kind of alcohol to clean the acrylic, and that embrittles it like you wouldn't believe. God, way back in the day, we had a 3D printer. It was one of the first Darwin models, which was threaded rod and acrylic bits all tied together. And someone cleaned off some of the acrylic bits with isopropyl, and like a week later, they all just like shattered. It was absolutely horrible. Yeah, no alcohol on acrylic.
And this actually also reminded me of a injection molding acrylic lens project that we covered a while back from Zachary Tong on Breaking Taps. He's actually going to be on the Hack Chat next week with us talking about microscopy. Not that he used these acrylic lenses that he made for microscopy, because he's talking atomic force microscopy and confocal laser scanning microscopy. So that's the kind of stuff we're going to be talking about. But it's still pretty cool that that you can make DIY injection molded acrylic lenses in your in the comfort of your own home.
Yeah, that guy's one of my new heroes. I love his videos. They're too long and they're just full of detail, and they're not playing to any of like the YouTube slapstick or like cheap shots. I just love that.
They're both too long and not long enough, in my opinion.
Exactly.
You know what I mean? That's like at the end of it, I want to watch more, and I know I'm going to have to wait till next time. So I'm looking forward to talking to him. I think that'll be a cool hack chat.
Oh, that's awesome. And if you're really into seriously grinding lenses, I was led to watch this video in the comments of some other Hackaday post. I can't even remember what it was. Sorry, whoever posted this there. It's a YouTube video. It's about an hour and a half long about building a telescope, and in particular the mirror on the back of the telescope yourself, with John Dobson. I guess he kind of invented this style of hobbyist / amateur telescope, which basically is just a really huge, well-made reflector at the end of a cardboard or wooden tube box. If you're interested in lens grinding and how you would make an actually precision telescope mirror, this video walks you through it from the very beginning. I'll give you a warning, it's basically just hard work.
The next one I picked was a hack by Michael Gardy. It's a fellow we had on the Hack Chat a while back, I think last year. Hack is a 2/3 scale VT100 terminal. It gets closer to its roots by Tom Nardi. Mike has taken it upon himself to preserve computer history through reproductions of classic bits of hardware that you might not consider to be part of computer history. For example, he's done trainers that salesmen used to take around. Like they're kind of like breadboard things, a little bit like the 101 kits that Radio Shack used to sell, where kids could hook up things with the spring terminals and wires and make some circuits. Kind of the same thing for Digital Logic to teach sales forces how to computer and therefore be able to sell them better. He rebuilt one of those. It was spectacular. Rebuilt a computer trainer that Claude Shannon came up with. So really impressive stuff that he's dug up from computer history and built these replicas of, mostly with 3D printing, but a lot of other technologies too. The VT100, everybody's probably seen a VT100. It's got a classic look to it. It just looks like the 70s kind of presentation. This actually would be a good application for the acrylic lenses on the front of an LCD screen to kind of recreate that CRT look. The first one that he built had what you would expect it to have as far as guts, Raspberry Pi, that kind of stuff. Because it's not supposed to be a reproduction, really. It's supposed to be a replica. He chose this path, and I get that, and that's fine. But Lars Brinkhoff got involved with it, and he loved the look of the 3D printed 2/3 sort of mini scale VT100, and he figured that maybe I could do a little something else with that. So he started developing a simulator that would run on this mini terminal, and it ended up looking fabulous. So it was another one of those examples of someone seeing something on Hackaday, or Hackaday.io in this case, and running with it in another direction, and the whole was more than the sum of the parts in this case.
I think it's funny though, where he has it running RetroPie and he's made an arcade game keyboard for it. So it's, it's got the joystick and the arcade buttons, and it's put into this like 2/3 scale keyboard case. I think that's lovely, but then I totally get that this needs to be turned into a serial terminal.
I like the OpenGL tricks to make it look like there's actually a electron beam scanning across the screen, putting in that glow around the characters and doing the sort of interrupted characters for each individual pixel. It at least gives that look of a CRT. And like I said, you slap one of those lenses on the front of this, and maybe somebody's doing a double take to see if it's really a CRT.
Bringing up the rear, a smart light bulb running Doom is a pretty bright idea. This is an awesome hack by Nikola Ryachin. I guess it started with the idea from Foon, who reverse engineered an electronic pregnancy stick and added another screen on it. I guess he added an OLED screen and ran a couple frames from Doom. Didn't actually get Doom running on the thing, mind you. But this inspired Nikola to think, what is kind of the lowest common denominator thing I could get Doom running on? And went shopping for light bulbs. In particular, the IKEA Trädfri, it's an A with a circle on the top, an angstrom. I don't know how it's pronounced. The IKEA Trädfri light bulb has a ridiculously powerful processor in it. And all you need to do to get it running Doom is a lot of hard work. Is tie on a screen, rewrite the open source PR boom code to work with an incredibly constrained RAM footprint, and solder a little bit of extra flash memory on there so you can fit the WAD files in. What? The craziest thing about this for me is how overpowered these IoT light bulbs are. They're running an 80 megahertz A33 processor. The thing has 108 kilobytes of RAM and 1 megabyte of flash on board. It's a beautiful little microcontroller. It's also an RF microcontroller, which I guess explains why it's in IoT light bulbs. But just the processing power alone is enough to run Doom if you're willing to cut some corners. I thought that was crazy. Again, the real work here is in shoehorning the versions of Doom to fit on this limited a microcontroller, and the real issue here is in RAM. Nikola points out to some Game Boy ports of Doom, but a Game Boy has 300 and something kilobytes of RAM, and this only has 108. So you can only load one level at a time, and you have to change all your variable names so that they're short. And there's actually a list of like 20 things that Nikola did to make it fit into this small amount of RAM. And it's a great list if anyone is out there having to size optimize code. There was a 32-bit address space that only needed to be 16 bits. And so every time you write one of these addresses down, you're cutting your memory use in half, right?
Pretty clever.
Yeah, there's a bunch of like hacky hacks going on in this one. It made me think of the last most impressive Doom we've seen, which was in just February. Sylvain Munot TNT got Doom running on an Ice 40. And again, what that and this have in common is they're kind of minimal devices. And so the game is to say, what's the least I can bring to this to make it run Doom? And when the least you can bring in is an 8 megabyte SPI flash chip, that's a pretty darn cool hack by me.
Yeah, and unfortunately, though,
Yeah.
very soon after I posted this, which the post that I did just didn't do it justice to the amount of detail that he had in the material that he wrote up.
You couldn't.
And I think he probably ended up leaving a lot of it out, too, because
Yeah.
of all the other things that needed to get done to make this happen. But unfortunately, very shortly after, he took it down, and took it down from everywhere. We don't know why he took it down. We can only speculate as to why. There was some speculation that it has something to do with IKEA getting mad at him, or, well, I don't know if Doom could get mad at him or not, but I guess Microsoft could get mad at him.
I think both of those are unlikely because PR Boom has been open source for, 15, 18, 20 years now. It's too late to be mad about that software and porting it. And IKEA was a little bit knee-jerky about one IKEA hacker website in 2014 because of trademark infringement, but then they backed off and said, you know what, this is totally reasonable use and go ahead. So I don't think it's either of them.
I mean, there's some speculation that it's his employer, but whatever it is, we respect it. It's fine. If it has to go, it had to go. It's just too bad because there was a lot of really juicy details in there that we were hoping to memorialize a little bit and everybody could share.
Well, it's not really gone. The Wayback Machine records everything.
Nothing's ever gone, right?
Just click on the first link in the article. It's all still there. You can't erase everything.
I may or may not have a theme here with my quick hack. See if you can detect what it is. But my first one is ham radio traffic logger using a bug in Baofeng Electronics. It's a quick and clever hack that Whiskey Tango Hotel uses to basically count traffic on his local 2-meter amateur repeater. Everybody knows the Baofeng. It's a $25 radio of questionable quality, but unquestionable utility. You keep a couple spares around. They're good for projects. There's a little bit of a bug in it. It turns an LED on that lights up the backlight of the display every time it receives a signal. And that actually causes a little bit of a pop on the speaker. So that means it's actually pretty easy to plug something into the headphone jack and you get a little voltage spike. That voltage spike means there's some sort of traffic on the air, and you can use that to get some statistics, do some metrics, that kind of thing. It's non-invasive, it's quick and easy, and it gets the job done, and that's my kind of hack. The next one up is APRS implemented at low cost and small size. Brian Cockfield wrote this one up. Tyler is the builder, and I have to be honest, APRS, automatic packet reporting system, I believe, has always kind of mystified me. Even being a ham, I know what it's for. It's just there's kind of this hurdle to getting into it that I've never really managed to get past because it's got such a low barrier to entry. It's an ESP32 based terminal node controller, basically just a fancy word for a modem. It's your gateway into the APRS system. So it's the thing that takes the packets, decodes them, takes your data, encodes them, and puts that out on the network. APRS can be used for things like position location. GPS can be plugged into an APRS radio. So there's a lot of good uses for it. Having something like this that's taking advantage of the wireless capabilities of the ESP32 to interface with an app called APRS Droid on a smartphone is a really low-cost way of getting into APRS, and I really appreciated that. And the last one is balloon antenna doesn't need a tower. Williams wrote this up. Our friend Josh over at Ham Radio Crash Course, he was actually another Hack Chat alumni. He was on last year, I believe. Has been going through a continuing series of will it antenna kind of posts. And basically what he ended up here with was a bunch of floral wire and some balloons from the dollar store to see if he could get an antenna lofted with nothing but helium. Had a little trouble with it at first, but actually did manage to get an antenna up there. It could be in certain improbable circumstances, could be a useful tip to keep in mind. especially with field day coming up.
Let's see, I'm guessing radio was the theme.
Something like that. Yeah, something.
My first quick hack is Alexa, bring me a beer. This is a video by Lewis Engineering. It starts off as a bold plan to have a computer vision enabled robot that will go fetch him a beer when he commands it over Alexa or something. In the end, it's a lot less computer vision and a lot more line following. And instead of sensing when it's close to the beer container, it hits it with the button and pulls the beer out. On the other hand, this is an awesome little robot that does, in fact, fetch him a beer. The video's in German. It's too bad. It's absolutely hilarious. If you speak German, you really should watch this one. If you don't, you will enjoy the magnet on the end of the arm that attaches to the bottle cap to pull the beer out. Next up, Mads Barncob. Digital X-ray scanner teardown yields bounty of engineering goodies. This X-ray scanner is simply a photo multiplier tube and then something to spread the signal out into a line. The really cool part here is the acrylic light pipe that feeds into the photo multiplier tube, and Mads does a great job of showing you how it works by pointing a green laser into it. You should really watch the video. Next up, Recore hacks the hidden microcontroller for 3D printing. This is a really super 3D printer controller board by Elias Bakan. A lot of people use Raspberry Pis or equivalent single board computers these days as part of their 3D printing chain, like running Octoprint on it, but can't use the computer core itself to drive the device because you need this kind of real-time control. So there's usually a microcontroller somewhere involved along the way. The super clever hack here is that the power management chip inside this A64 SoC that he's designed around is actually a little independent microcontroller, and he's figured out a way to make it do the real-time stuff. So this is a beautiful combination of single board computer and abuse of this little embedded microcontroller to do the real-time motor control. I love this one. Which brings us to Can't Miss articles. These are long-form articles written by our Hackaday staff. What have you got this week, Dan?
The article I picked was The Other First Computer, Konrad Zuse and the Z3 by Chris Lott. One of the things I liked about this was the opening of this article read kind of like a Jean Carré novel or something like that, a little spy story kind of thing, war intrigue and all that. So Chris did a nice job with that. But the other reason is no matter what you think is the first fill in the blank, there's always going to be someone else who says, oh yeah, but did you know that ... did it first? Edison with a light bulb, list could go on. And someone will always come back with someone else who did it first. And those data points are always interesting, sometimes a little spurious, sometimes a little overly pedantic. But in this case, I think Konrad Zuse has a pretty good claim to have built the first practical programmable computer that architecturally looks like the kind of thing that we would expect to see today. The really interesting thing to me about this whole process was the iterative design that he used and the way that he started with basically straight mechanical computation, basically mechanical NOR gates. I thought that was crazy. Absolutely fascinating. It was born of necessity. There wasn't anything else for him to do this kind of calculation with. And basically what he was trying to do was making his life as an engineer easier, to automate the calculations that he was a civil engineer. And he had a lot of repetitive calculations to do and was trying to find a way to make it easier. So that's another thing that's kind of near and dear to my heart. When I was in grad school, I was much more interested in doing cool things with data capture and automating my processes rather than caring about what the science was that I was actually doing. It was the techniques that were more interesting to me. And I think he kind of felt the same way. But being able to get it done with nothing but these mechanical linkages and a hand crank or an electric motor to power the whole thing was kind of a step backwards to the Babbage engine that never was, the analytical engine that never became real. But what are you going to do when the only thing that's available is cast off relays from a telephone exchange that were probably cast off for a good reason? You figure it out. And vacuum tubes hadn't really come along yet and were too expensive anyways and not reliable enough. But mechanical linkages kind of, as long as you keep everything oiled and adjusted, you're probably going to be pretty reliable. And he managed to get things done. The Z1 became the Z2 and it became the Z3, which is the one that really sort of nailed it. But it took all of those principles that the previous computers had explored mechanically or electromechanically and made them into the architectural elements of computers that we're all familiar with today. And I think that's really fascinating that it didn't really matter what the physical manifestation was, whether it was a mechanical, bit of metal moving together, or if it was silicon transistors on a chip. It's the same thing when you abstract it to the level of control that he did with these architectural elements. Good on him. It was a story it was a good read. Plus the circumstances under which he was working on these things, constantly being bombed, constantly having to move around and all that stuff. There's obviously going to be arguments about, who he was working for at the time. He was working at the Henschel aircraft plant for a while, working on bombers and on radio controlled, like basically drones. Yeah, well, it was war and he was on the wrong side of history, but he did manage to make quite a lot of contributions. And I guess his son actually has developed a site and kind of kept his inventions alive, at least in virtual form, so that everybody will know, where all this stuff that we use all the time came from.
What's really neat about this, you mentioned that he's kind of doing this development of computers under difficult circumstances. It's like difficult 5 different ways.
Yeah.
First of all, he's working for the Nazis at this point in time, but they don't care about anything that isn't directly a killing machine. So he's basically like trying to sell them on these computing ideas, and they're rebuffing him and saying, this isn't directly useful. Unlike contrast the English, who, were building Colossus and the bomb and, they're kind of code breaking computers at the same time, who at least their military understood the use of these things, whereas it looks like the Nazis absolutely did not. There's also resource constraints at this point in time. But then the other thing is there's literature constraints. He was kind of cut off from the international flow of ideas developing at this point in time about computers. It turns out he didn't read about Shannon and the idea of bits until after the war. So he was doing all of this work kind of reinventing a lot of the things that other people had been doing and sharing in America and England in particular here. But he was kind of forced to work in isolation in this weird way. So it does make it, in that sense, a lot more impressive. I love and like you said, I love the stopgap nature of, I'm going to make this mechanical computer first, and then, I got my hands on a whole bunch of relays. Okay, it's going to be a relay computer now. It's just build it with what you got. One of those replicas, I'm going to have to go record it for you guys. One of the replicas of the Z3 is actually in the Science Museum here in Munich. And I've seen it. I don't remember if it was running or not. Like, it's a relay computer, so you really want to hear the thing running. If I go there and can get some audio of it, I'll definitely bring it back for the podcast.
There was a good quip there. Someone said this replica of the Z3 is spot on for the original Z3 because neither of them worked very well.
My Can't Miss article this week is Rhizotope, addressing poaching by making rhinoceros horns radioactive. Maya Posh wrote this one up for us. It's a really interesting conservation effort. The problem is that rhinos are endangered and are probably going to die out maybe entirely in the next 20 years unless we can do something really quick. And one of the biggest problems, besides habitat being destroyed, is that they are poached for their horns because some people think that rhinoceros horns make you more virile or something. The solution proposed here is an interesting one. It's to inject the horns with enough of a radioactive element that gives off gamma particles so that it would render the horns essentially too hot to smuggle. Like if you were trying to get these through an airport or through a container ship, it would be so blindingly red hot that the radiation detectors that are otherwise there to detect, smuggled uranium or smuggled, I don't know, what's the radioactive substance that you're smuggling these days?
Yellow cake uranium or plutonium, I guess. Plutonium would be that's so expensive.
Anyway, the point is that we've got this entire apparatus for detecting radioactive smuggling. Why not turn it to help out the rhinoceroses? And I think that's really clever. You can inject them with enough of a radioisotope so that their horn is essentially tagged, but it's not enough that it does any harm to them. And figuring out which isotope you want to use and how much to dose them, and then getting out into the field and doing it is one thing. I don't know how long it will take until all of the poachers realize that they won't be able to get these things through customs ever. That part, that's the hard part of this. That's where, I wish they had a better solution. On the other hand, what I really like about this is it puts the pressure on the people who are doing the trafficking in the horns. Because as much as you kind of want to blame the people doing the poaching, they're honestly people who live in extreme poverty. And this is they're not doing this to become rich. They're doing this to have enough money to get food. And the people who are getting rich off of this is the middlemen and the smugglers. And so putting the radioactive isotope in there puts them under the radar of, security in ports, harbors, and airports. So I really like that aspect of this. I don't know, really clever idea, I thought.
Yeah, I agree. I think it's a clever idea, but, you got to kind of analyze it and see if there's any way that this can be gamed by the poachers.
Yeah.
Are they going to maybe just decide that the risk is worth it and still take that if it's not tainted per se? I mean, because they did say at one point they injected some sort of poison into the horn that wouldn't hurt the rhino but would make it toxic for ingestion by the at the final end of the smuggling chain by the consumer. That seems a little unethical, I guess. I mean, you're basically just saying, okay, these people are going to take this stuff and they're going to get hurt by it. I don't think that really works.
The problem is that it's superstitious people on the demand side, and it's desperate people on the supply side.
Yeah,
and then it's these poachers in the middle. And so those are the people you really want to put the hurt on.
Technically, I just wonder, how hot are you making these things so that they can get detected in port security? I mean, you're talking a steel shipping container? Are you talking...
I could answer that, but I would have to kill you. I presume nobody knows the exact amount of gamma-emitting radioisotopes you have to have in a container to trigger the detectors, right?
Right, but then again, lead bricks are pretty cheap. I mean, that could be something that someone just bulks up on lead bricks or lead foil or something like that and wraps a bunch of this stuff in there and nobody's the wiser. I hope it works because the idea that someone would just come up and kill a rhino just to saw off its horn is repulsive. Although I gotta say, there's one picture in this article where they're showing basically, I guess you'd call it prophylactic surgery. They're dehorning the rhino, who is presumably anesthetized, but somebody's still got to walk up to a full-grown adult male rhino with a chainsaw and say, "Here you go. You're going to have a little procedure here." Somebody's got a lot of courage to be able to get that done.
I do think that the preventatively cutting off their horns solution is kind of the big winner because none of the poachers are going to shoot a rhino without his horn. But then they talk about the damage that does to them and what they use their horns for and stuff like that.
Right. They need it for their mating courtship or rituals and, it's defense too.
I feel bad, but I guess that's the question is, are we yet to the point where it's worth doing that just to save the animals entirely?
Yeah, it may well be.
And we may well be.
Raises some interesting questions, and I hope this is something that actually moves the ball a little further down the road to saving these animals, because they are pretty magnificent animals.
I was at the zoo, and we were walking by one of the rhinos, and they can pee about 10 yards, 20 yards, and they can do it straight back. And so we were walking by the rhino, and we were about 10 or 20 yards away, and he was aiming at this wall, and just this jet of urine came out of him, basically horizontal in midair, hit this wall, and of course splashed all over us. Thank you very much. But it was it was completely shocking. He wasn't aiming at us. We were just, caught in the crossfire. But man, I got peed on by a rhino. That's all the time we have for the Hackaday podcast this week. Thanks for listening. If you'd like to read any of the links, they are on the website, hackaday.com/podcast. We love to get tips from you, so write in tips@hackaday.com. And until next week,
keep on hacking.
Good. Don't ask me, man. I hate computers.
I miss cassette tapes. All right.
Memo to self, handle it in post. All good.
Quick hacks. Okay.
Okay, here we go.
Backlight on the display. God damn it. What am I trying to say here?
Okay, you ready for some can't miss articles?
Does that make any sense at all?
Done. We are done.